Welcome to Daily Physics. So today we have two guests. I invited Shibono from NYU, who are going to give you a good understanding of today's topic, which is non-inertial reference frame. And more than that, we have the god of physics, Ralph Berry from Brown University.
The word God should be filing a restraining order against him right now.
Okay, don't be jealous, baby. Just because he is good in physics doesn't mean you have to feel bad.
He's good in physics? Wow,
Yeah.
that's news. Can you tell me more funny jokes?
Okay, all right, we'll
Wow.
see. All right, so today's topic is non-inertial reference frame. We're going to try to understand something we already understood yesterday, and that is inertial reference frame.
Inertial reference frame is a frame that's not accelerating.
That's it.
Oh, yeah, you're right.
Yeah, that's it.
There's no force in the reference frame.
You don't want
Not
to say
accelerating.
you don't want to say too much. You just want to keep it as simple as possible. So baby born today, understand it.
Okay.
Okay, so inertial reference frame is a reference frame, doesn't accelerate. Okay, reference frame itself doesn't accelerate. Anything inside the reference frame or on the reference frame can accelerate. For example, Earth. Things accelerate if you drop.
Yeah, everything accelerates, but the Earth's acceleration is relatively very small. So
with
that means we
respect to
can almost treat it
that's right.
like an inertial reference frame.
Okay.
Of course, this is not news because we talked about this last time.
Well, okay, so one of my students, speaking of that, one of my students used to explain this one. If you consider a big ball and call it Earth, and if you consider a small ball, call it Moon. Okay, so now you don't see it, right? Do you?
I see.
You have to tilt it more to the. Oh yeah, I can see it.
So if what do you call this arrow? What do you call this vector?
Well, that's the force of the Earth on the Moon gravitationally.
Force on Moon
by the Earth.
By the Earth.
Yeah, make sure we make it clear, as much clear as possible. Okay, good. Now, the Earth, okay, the student said, this is a student perspective. A student said, Mr. Berry, the Earth does not fall and collide, the Moon doesn't fall and collide with the Earth, is because the Moon is orbiting circular. However, there is another force which is 180 degree opposite from the center.
Well, that depends what reference frame you're in.
Centrifugal force.
No, yes, centrifugal force.
Well, the centrifugal force only exists in a rotating reference frame.
And what he said that this one is G-M over R square, and this one is...
No, can I just give you the simplest explanation of why it doesn't crash?
Square over R, and they are equal in magnitude, opposite in direction. Therefore, what happened? Moon doesn't fall on the R.
Well, yeah, but that force only exists in some reference frames. Can I show you the simplest reason why?
Why?
Okay, let's say you are about to fall into a pit of spikes. So you are currently falling downward. Then you move perpendicularly. What happens? You are no longer falling on the pit of spikes. You've dodged it. Just like that, the Moon is currently falling towards the Earth. But while it's falling, it's also constantly dodging the Earth. And so it moves this way. And so while it's falling this way, it's constantly dodging the Earth, which moves it this way. And while it's falling, it's dodging the Earth. So the Moon is stuck in a cycle of dodging the Earth over and over that keeps it stuck in an orbit.
Okay, now this is from the perspective of who? Someone is standing on the Moon or someone is standing on the Earth?
On the Earth.
Okay.
On the Earth.
So this is someone is standing on the Earth. Okay.
All
right, we're going to come back to this problem once we do the easier one, okay? And that is inertial versus non-inertial. I'm going to take you to the elevator. Let's say John is 50 kilogram.
Fatty.
And let's say acceleration due to gravity is 10 meter per second squared, so that we don't have to use a calculator. Okay, good. So now what you want to do is over here, I want to put the elevator over here. Do you see the elevator?
Yeah. Yeah.
Yes.
Okay.
No, I'm blind. Please help me.
So
Oh.
elevator is accelerating at 2 meter per second. It's
Okay. Okay.
right?
Are you sure?
Mhm.
And there is a scale over here. Okay. And Isaac is standing outside the elevator.
Mhm.
Alligator?
Isaac.
Mm.
Isaac is standing outside the elevator. Did I say alligator?
Yes.
Okay.
I think you've got a lot of alligators on your mind.
Oh, shit. Okay.
You asked me earlier, could an alligator beat a tiger? I think you really like alligators for some reason.
Okay. All right. Okay. So this is Isaac. Isaac looking the elevator. Elevator is made of glass or whatever. Isaac can see through.
Mhm.
Okay. And there is John standing on the what?
On the scale?
On the scale. All right. Can you draw a free body diagram and find what would be the reading on the scale? Both of you, go ahead.
Okay. So
Wait a second. He's 50 kilograms in which reference frame?
I said that Isaac is outside.
Oh, wait a second. Mass doesn't matter. Okay.
Isaac perspective.
okay, so here's so
Draw
then,
free body diagram, baby.
okay.
And you have to use, you're gonna have to tell me, oh, by the way, Isaac, can I have your
Yeah.
attention for 1 second, Ref?
Yeah.
Is this inertial reference frame or non-inertial, Isaac?
The elevator.
Whose reference frame?
I said that Isaac is outside. I made it clear.
Yeah, Isaac's reference frame is
Okay.
inertial.
Yeah.
Okay, so inertial reference frame.
Well, yeah, you made it clear, but you didn't specify whose reference frame you were asking about.
Isaac, okay, good. Now, second question. No, don't move. Second question. Can we use Newton's second law?
Yes, because it's an
Yes.
inertial
Newton's
reference.
second law hold. Is
Yeah.
that right?
Yes.
So I want you to use Newton's second law and free body diagram. Go ahead.
Okay.
That means you have to write F net is equal to ma.
Dad, can you see what I write or
I do.
no?
I do.
Okay.
You must write F net is equal to ma because you said Newton's second law hold.
Okay. So, what is the acceleration here, and what is the net force? Well, if you really think about it.
No, no teaching. Just go ahead, solve it, baby.
Okay, fine. I actually.
Dad, I think he actually doesn't know how to solve it. That's why.
Can you stop, Ref?
Oh.
Just
wow.
because you memorized how to solve it doesn't mean I
Oh,
don't.
I memorized it from what, like 5 years ago? Oops.
Yeah, you did memorize it from 5 years ago. Who's saying you can't do that?
Okay, Isaac,
Okay.
go ahead. I want to see the free body diagram, baby, with the red
Okay.
color. You have a red chalk.
Okay, fine.
Okay, Dad, I got it.
Okay.
So you have FG, you have FN, but FN is the one that the weight scale measures. It can't obviously measure FG. And so
you have FN?
Shut up!
Don't
Okay,
you
go
also
ahead.
have like a skill issue?
Go ahead.
I'm going to throw this chalk at you, and you are going to shut up unless you want me to throw this chalk in your mouth. Alright, so FN is different from FG.
You will break Brown University rules if you throw chalk at him.
Am I from Brown University? No. Do I
No.
care about Brown
Okay.
University's rules? No. Hence, I will shove this chalk in his mouth.
Okay.
Alright, now that that's all done, so FN and FG are totally different because of the extra 2 meters per second squared. So, what's the difference between them? Well, it's just going to
Bro, it's not rocket science. It's just you add FN and MA. Okay,
Yeah,
fine.
okay.
Sorry.
Okay. Jeez. Man.
Sorry.
You suck.
I'm sorry. Sorry. You
Well,
did.
actually, the answer is already on your screen, so why should I bother?
No,
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 go
no, no.
ahead. Go
Sorry,
ahead.
sorry.
Finish it.
Keep going. Keep going.
No, I
No,
mean,
sorry.
why should I bother? The answer is already on your screen.
No, 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 no. Keep going. It's
That's not
nice.
the answer?
It is, but can you
Yeah,
give
but
us explanation, baby?
But why should I?
no,
Okay.
I like your explanation. Yeah, yeah, yeah.
Man, I mean, it's every step is obvious. The net force, well, it's right there. It's just one force subtracted from the other. One of the forces is Fn, one of the forces is Fg, and the elevator is moving up at 2 meters per second squared, so clearly that's the acceleration. So now Fn is equal to m times 2 plus mg. And what are we supposed to be finding here? The reading
The
of the
scale,
scale?
what
Well, that's just going to
value
be
is
his
scalar
mass is
weight?
50 kilograms times 2. His mass is 50 kilograms times 10, which means the reading of the scale is going to be 100 plus 500 or 600. Why couldn't you have just read it off? Every step here is obvious.
Okay, now, can you lower it so we can see your math? Okay,
Well,
good.
you don't need to see the math. It's already on ref screen.
Okay, so now, this time, eyes are gonna be inside the elevator, and we see that what gonna happen and what gonna change. Okay, I will do it here. Now the elevator is here. However, it is accelerating at 2 meter per second square. However, Isaac is standing over here. Okay, and of course John is there. John doesn't care. John is, I don't know, nobody cares about John. All right, now we're gonna measure everything in terms of Isaac perspective. All right, now can you find what do Isaac see on the scale? You have to do the free body diagram, and you have to use whatever you have to use.
Okay.
What is the question I ask you? Don't erase anything, baby.
What's Isaac's mass?
No, not Isaac mass. Isaac is not standing on the scale.
Okay, so
I
what
John is standing on the scale. Isaac is just inside the elevator,
Oh, okay.
looking at the scale.
Okay.
Isaac is inside the elevator, baby.
Okay. Is that good?
Isaac is inside the elevator.
Yes.
Okay.
This is it.
No, that John. That guy is John is standing on the.
No, that's this diagram.
No,
The
it's
fat guy's John.
fat guy is why fat guy is outside now.
Well, you said John is standing on the scale outside while Isaac is in
No,
the elevator. Oh,
no,
both of them are inside?
both of them inside.
Okay.
Okay, and Isaac, look at the scale.
Okay.
Okay, Isaac, look at the scale. What does Isaac see?
Well, okay.
Now, first, let me know, Isaac, is this inertial reference frame or non-inertial
Well,
reference?
now it's no longer inertial because both of them are accelerating.
So we're gonna say non-inertial with respect to who?
Well, with respect to Isaac and with respect to John.
Isaac. Well, John was not paying attention to anything. He was not measuring. So let's not involve him. He was not the one measuring. Isaac is the scientist. He is measuring things. Okay, great. Now, do Newton's second law hold?
No.
No.
So now, do you think Isaac looking at the scale? Yes, he does.
Yeah.
What does he see? Can you go ahead?
Hmm.
Do the
Well-
math, do the free body diagram, and of course,
Why does it matter? The scale doesn't change
no,
position.
you do the
The,
math.
the value that the scale displays is only dependent on the scale's reference frame. Now, I mean, why would it change from here to there?
Do the math
Okay.
without talking. Let's see who can. You don't want to reveal too much.
Okay. So here we can't exactly use. Well,
What if I?
no, I can't use this anymore because there's an external acceleration. So what if I just account for the external acceleration? I know. By saying something like this.
Hmm.
I'm gonna give you 60 more seconds to solve and show me an answer.
Okay.
Okay, I think I I'm not sure, but I think he would just see
They should see the same
the
value.
rate.
Write down the value, baby. Whatever he see, can you write down the value? I want to
Okay.
see the math. I want to see the math. I just don't. Isaac wrote the math. Raf, you did not write any math.
Okay. Uh,
Ref does math, not math.
let me see. Okay, wait. Let me choose.
Ah.
So this is a non-inertial frame. I can't use F equals ma. But
Okay,
Yeah, I
so
could account for
so
that.
should I say that? Say give you a hint.
wait, no. Wait,
All right.
I have an idea.
So you have to that's called fictitious force. You have to faking it. Okay? You have to fake in a way
Which fictitious force do you introduce?
Newton's second law work. Okay, like Isaac did, and he erased it. I don't know why. He did it without naming it fictitious force. Okay?
Okay.
Okay, because according to the Isaac, is Isaac accelerating? No. Is Isaac accelerating?
No.
Isaac
No.
is
Okay.
not. Isaac is not
I don't
accelerating.
know why I erased it. That's stupid.
So there's a fake force that
How did
acts against
ah?
the real
Yeah, Isaac
acceleration.
had it. He erased it.
I don't know
Oh.
why.
Okay, I'll call this F fake. Okay. So
So you
okay,
have to fake it so that Newton's second law work.
okay. Wow. Okay, so then okay, I got it. I think I got it. Okay, so now the net force
Oh,
on
you're
the
not.
object
I'm
has
stupid.
to be zero.
Hey, are
So
you looking at my screen?
no,
You said
Fn.
that exactly as I wrote down zero.
Oh, Fn minus Fg minus F fake is zero. So now I can just solve for Fn. Fn is Fg plus the fictitious force.
Yeah, it's the exact same answer.
Oh wow.
As long as you introduce the fictitious force.
And
So
the
Why did
fictitious
I
force.
erase it?
now, why our student? Again, this is not. Although you guys are expert in physics,
Wow.
we are not doing undergrad level or graduate level physics. We are always trying to solve the 12th grade or even below 12th grade. Our audience is 6th grade to 12th grade, so that this is the time to recruit people. You don't want to recruit someone already in graduate school. You want to recruit someone who is 10-year, 15-year old, and
Mhm.
that 10-year can change the world. So that's our audience, 10-year old, our audience. So we are keeping that level. Now, Isaac, can you tell us where our physics teachers failed our student to help this high school level or maybe middle
I
school
know I
level?
don't teach physics.
Ref.
Yeah, so non-inertial reference frames are not usually explained in high school physics, and especially the
Really?
centrifugal
Where is
force
the
is
at
not.
exactly what location at exactly where
Oh yeah, that's one big problem. In high
the
school
physics
physics,
teacher lost the opportunity to explain it?
yeah, in high school physics, I was never really taught why the centrifugal force.
Yeah.
There you go.
Yeah.
Centrifugal force is also a fake force,
It was
Hmm.
kind of just shoved into.
just like this one.
Yeah.
Okay, now
Yeah.
Isaac, can you then take us that earth and moon thing and help us understand centrifugal force?
All right.
Okay.
Sure, I guess.
Okay. So let me draw it first.
Uh-huh.
Or
No, I don't need a drawing.
no. Just draw a diagram so I can understand it. So this is our Earth, and this
Okay,
is our
so you
moon.
have.
Okay. So why our moon doesn't fall on Earth?
Well, the centripetal force is not fictitious at all, but the centrifugal force is very fictitious. So let's.
It's a fake force designed so
To
that the net
Newton's
force
second
is
law
zero.
work. Newton's second law works.
Oh
Okay.
yeah, yeah.
Oh, okay. Wow.
It's designed so that there's no tangential. No, sorry, that there's no radial acceleration.
Okay, let's say the centrifugal force was not there. Then the moon would
Oh
be
no, you have
forced.
to change the reference frame for centrifugal force. Now Isaac has to be on the moon. So can you say that,
Okay.
Isaac? Your
Oh yeah,
location
yeah.
is no longer on Earth. You are on the moon. Otherwise, there is no centrifugal force. Our physics teacher never said that.
Yeah,
Wait,
exactly.
Dad, can you
So-
say it again?
If you are on the Earth, then there is no centrifugal force.
Yeah,
There is only
There-
one force, which is force due to gravity.
Yeah, you see the force due to gravity, which works as the centripetal force, and you say, well, I mean, the moon is accelerating.
So now, can you write you are on the moon, Isaac, so that our
Yeah, so from here, you can see that it's accelerating. The net force is not equal to zero on the moon. So the net
Okay.
force on the moon is not equal to zero. And
Okay.
so it
Okay.
makes sense that this guy is there. But then,
don't
when
block,
you're
don't block,
on the
don't
moon-
block, don't block.
Shibo,
This guy,
are you frozen?
no,
Oh, okay, okay.
this guy says, well, I'm not accelerating. My net force is currently zero.
Oh,
Yet,
I
I'm
see.
not dead.
So
Which
therefore,
means
there must be a fake force acting the opposite way.
there must be another force in my
Okay.
reference frame that's stopping FG from killing us
Okay.
all. And
I
yet the
see.
Earth guy doesn't perceive that because
Mhm.
he says the force is not equal to zero.
Okay, now
Okay.
Isaac, Raf, now can you
Okay.
draw? Can you
Uh-huh.
draw a diagram when Raf is on the Earth and he look at the moon?
Yeah. Sure.
Well, I just did.
You did Raf is on the moon.
No, I did the Earth one as well.
Oh, you did Earth one?
Oh, okay. Here, let me also do it.
You
So
can't
that-
see because of the lights, but.
Oh, okay.
Okay, so here's the Earth, here's the moon.
Mm-hmm.
Okay, so
Okay.
draw all the force. Okay, very good. So can you write one? You are on the Earth, so put yourself on the Earth.
Okay.
One, you are on the moon.
Okay.
So write you are. Which one is inertial? Which one is non-inertial?
Okay, so the Earth is inertial reference frame with respect to
If you are looking at the moon,
with respect to the sun.
if come on, if you are looking at the moon,
Yeah.
now then Earth is a reference frame. Then it
Yeah.
is non-inertial. If you're looking at the moon, it is non-inertial, right?
No, if you look at the moon, on Earth, your reference frame is not inertial. You're not accelerating
Very
with your
good.
own reference frame
It's
on the
inertial.
Earth.
So can you
But
write
you look at the moon and you think, well, the moon is definitely accelerating.
Right.
I see it accelerating.
Very nice.
So,
So can you write, Raf? Can you write inertial and non-inertial?
Yeah, okay, so if you're on the Earth is an inertial reference frame,
Mhm.
but the moon is accelerating, so this is not
No,
inertial.
no. Why you have to write that? That's gonna go to the other side. Draw the free body diagram on the moon.
Okay, so if you're looking at the moon from the Earth, then you
That's
only
it.
see
That's
this.
the only force. And draw the acceleration vector now.
For this one.
For the moon, acceleration vector.
yeah,
It's the
the
same
moon
direction.
is tricky because the moon is a
Can you
non-inertial
draw the
reference.
second vector to show the acceleration vector?
Yeah,
The acceleration and force are the exact
It's
same
the
in this
same.
case.
Okay, centrifugal
Same thing.
acceleration. Okay.
But yeah, here you have the
Okay.
Centrifugal.
All right. Okay, help us
So here,
understand now.
so here there is no acceleration from this reference frame. But,
Well, yeah.
but that's because this is a non-inertial reference frame, right?
Okay,
So-
write non-inertial reference frame.
Okay.
Okay. All right. So help us, give us summary.
Okay. So
You feel zero acceleration on the moon, but clearly it's not zero acceleration, so you make up a fake force in order to make sure Newton's second law is still satisfied.
but why
It's
do you
pretty much
feel
it.
a zero force on the moon?
Well, you will always feel you will always feel zero acceleration if you're standing still in your own reference frame.
Okay.
So even if your
like-
acceleration is significant from
it's like-
somebody else's point of view, which
Okay.
means that you have to make up a fictitious force that nobody else can see in order to explain the fact that you're somehow not accelerating, even though everyone says you're accelerating.
Isn't it like elevator? Okay, if your elevator is accelerating and you inside the elevator, you have no idea that elevator is accelerating.
Yeah. Okay.
So this is a non-inertial reference frame? So
Yeah.
okay, if the Earth is orbiting the sun, then how can the Earth be an inertial reference frame?
Well, it is not an inertial reference frame, but the Earth orbits the Sun so slowly, the force is so minimal that you can
What?
basically.
0.00006 meter per second square.
That's the centripetal acceleration, but
Well, yeah, that's the only acceleration that's significant.
That's it.
yeah, okay, but
What else is there? The moon?
no, but there's still a centrifugal force acting on the Earth.
Yeah, but it's. It's ignorable. Of course, there's a centrifugal force acting on every rotating object.
You mean every orbiting object? That's different.
Yes. Oh
That's
my God.
different. That's different.
I'm going to punch you. If something is rotating, it has to rotate around something. Okay?
No, rotating around it, you can rotate around its own axis. That's rotational acceleration.
Oh, so
Different
then
from
that creates the
centripetal
Coriolis force.
acceleration.
Okay, great. I'm going to punch you now.
Just because you lost the argument, you can't.
Shut up!
Okay.
Man.
But okay. So let me make sure I understand. So the moon is a non-inertial reference frame because if you're the moon obviously has centripetal acceleration, but I guess the centripetal acceleration of the moon is much bigger than the centripetal acceleration of the Earth around the sun.
Yes.
So is that
So
is
its
that-
acceleration becomes non-ignorable, and so that means the centrifugal force is actually sizable enough to be treated as.
Yeah, that's I think this is a good question to check what would be the moon acceleration.
Yeah.
I don't think there is a single inertial reference
can you
frame in the
can you
universe.
find it? No, you can find it. The
Yeah,
force.
sure.
The net force is no, don't look at it. Net force is 2 times 10 raised to 20 Newton. So from the net force you can find the centripetal acceleration.
Well, yeah, but why is that necessary?
What was the net force? 2
2 times 10 raised to 20 Newton.
Okay.
I don't know the mass of the moon or anything.
Yeah, mass of the moon is 7.24 times 10 raised to 22.
35?
7
22.
just 7 times 10 raised to 24.
So it's somewhere on the order of 10 to the minus 3,
Okay, so
which is significant.
But we're gonna check our math is correct using the internet.
Oh,
Okay.
is it 22 or 24?
24. Oh no, 22, baby.
Oh, 22. Okay. 22. Okay, v squared. Oh, that's what we are trying to
No,
find.
F equal ma gonna do the job
Man,
because
you're trying to find the acceleration. You're a dumb one.
Sorry. Yeah.
Velocity doesn't matter when we're considering
Okay.
if the frame is inertial.
Yeah.
There is other
Okay.
way, rough way of doing it. The 2 pi r of
Yeah. Okay, I got it. Yeah. So this is
no, not b square over r. F over m. F over m. F is
Oh yeah. I could also do that. Yeah. Okay. So this is 2 over 7 times 10 to the
Man,
minus
how did
3.
you forget A equals F over M until.
Hey,
Are you
Hey,
sure
hey.
you're the god of physics?
Not right now, but I was the god of physics this morning.
The God keeps low profile here.
Hey, you can give the same excuse for me. It's 11 o'clock. I'm
Okay.
tired.
No. You
All
can't
right.
use time
Okay.
as an
So find
excuse.
out. Raf,
Okay.
find out.
So 2/7. Okay. What is 2/7 about? Point
Man,
five.
how stupid are you? It's 0.28.
Oh, 0.28. Okay. So
0.28 times 10 raised to negative 2. So is 3 times 10 raised to? 3 times 10 raised to negative
Oh my
3.
god, you're putting the power higher? Oh my.
okay.
So is
You
point.
really need to be institutionalized.
Okay, so we can ignore it. It's
Okay.
0.0003.
Oh, nice. And for the Earth, it's 10 to the minus 6, right?
10 to the minus 4, I believe.
Okay.
Well, it's significant. The moon,
How it is?
But
the moon makes a full
look.
orbit
You
once every
notice it
30
doesn't.
days. That's
Look,
pretty short.
the centrifugal force does not depend on the mass of the moon, right?
Centrifugal.
Wait, no, not.
Sorry, centrifugal is. I mean the acceleration. I mean the centripetal acceleration. It doesn't
Right.
depend on the mass of the
That's right. It
moon.
does not.
It depends on the mass of what the moon is orbiting.
Right. Right.
Because V depends on M. So
Oh, wait a minute.
yeah,
It 10 raised to f over m. Is it big M, f over big M, or small m?
this one.
Small m. We're measuring the
This one
acceleration
is
of the
small
moon
m.
here.
This one is small m.
We don't care about the
But
acceleration of
but
the
if
Earth.
you plug in the F, you will see the small m cancels out. The big M remains.
So can you now check on the internet that what is the actually acceleration of the moon?
Okay.
Isaac also check. Isaac check that. Isaac check
Centripetal
out. Rev check moon.
Um, gravitation of the moon.
centripetal
Yeah, Isaac have
acceleration.
to type what is the centrifugal acceleration of Earth with respect
Oh
to.
wow, it's 0.003.
What the?
Yeah.
It says 2.78 times 10 to the minus 3.
So we are right.
Yeah.
Yes.
Cool.
Wow. Okay.
Wow.
Sure.
Good
Amazing.
morning.
All right. So Rev, can you summarize it?
Yeah. So if you are if you are standing in a non-inertial reference frame, first of all, what does a non-inertial reference frame mean? It means that you're accelerating. Your frame is accelerating with respect to an inertial reference frame. That's what non-inertial means. You're accelerating. But if you are standing inside the non-inertial reference frame, then you are not moving, right? Because you are inside the frame. So somehow you have to create a fake force that that cancels out
Blah, blah, blah.
the other forces, so that the net force acting on you is zero in the non-inertial reference frame. So that's why you have the fake
Blah, blah.
forces whenever you're in a non-inertial reference frame.
Blah.
Why do we create those fake force, Isaac?
Okay, so essentially, people living in non-inertial reference frames are like conspiracy theorists, right? I know that's a stupid comparison to make, but just hear me out. So, person A is in an inertial reference frame, and he says, "Hey B, how are you doing?" And B is in a non-inertial reference frame. I don't know. He's like skateboarding.
Oh, that's wrong.
Isaac, you have 20 seconds. Sorry.
What? So he's accelerating with some speed, according to A. So A says, "Hey B, you're accelerating at 2 meters per second squared." And B says, "But I don't see any curvature of the Earth. I mean, but I don't see any acceleration. Man, I think you're accelerating away from me at 2 meters per second squared."
Ah.
And so he says, "Well, let's see. Because you like Newton's second law so much, I'm going to invent a fake force in order to show you that I'm actually moving at 0 meters per second squared." And then A says, "Yeah, sure. But that fake force only exists in your own head."
Oh God, yeah, that's
And
good.
of course, that's true. It only exists in his own reference frame.
Now wait. In this guy's reference frame, the guy on the skateboard,
is
there
accelerating away.
is no forward force.
Let's say
Ref,
the force is being caused
ref,
by him skateboarding.
ref.
Yeah.
Einstein's happiest thought would be a man
Can you
falling,
please let
right?
me speak?
Yes.
Yeah. How do you think people who skateboard start moving? They use
Yeah,
their feet to
but no.
accelerate.
Okay, let's just imagine it's an electric skateboard or something. Okay, so but then there is no force. There for the guy on the skateboard, there is no force pushing him forward, so he doesn't
Yeah,
need.
exactly. That's why he makes up the fake force.
Yeah, no, but this is different. I think this is different. This is this is the fact that okay, there is no fictitious force here. Okay, it's
Yes,
just
there
you're
is.
changing reference frames, so it looks like the guy who is on the ground is moving to the left when you switch
No,
to the
that's
skateboard
not what I'm
reference frame.
talking about.
There
This
is no
isn't.
fictitious force here.
Okay, maybe I have to make the text bigger. There's a squared there. If you
Yeah, no,
can't.
I see that. Yeah,
Yeah,
but
he's accelerating away with the force of his foot. That's how skateboarders start moving. Do you get what I mean? A skateboarder starts moving by applying an initial force to accelerate themselves away. And so, because he's accelerating in this guy's reference frame, but he doesn't perceive any
All right,
acceleration himself, he
everybody.
makes up a fictitious force that's pulling him away from the so-called force that A is talking about.